In this video, we will learn how to compute standard normal probabilities. Notice that the fact that we use standard normal curves means we're dealing with z-scores. Standard normal curve always is centered at the mean of 0 and has a standard deviation of 1. Let z be a standard normal random variable. Calculate the following probabilities using the calculator provided. Round your responses to at least 3 decimal places. So first of all, we will round to 3 decimal places, and second, I would like to mention that a calculator feature of ALEKS may not be available to you depending which course you're taking, because sometimes I am disabling that option and you will have to use your TI-84 calculator for that reason. But I will demonstrate how to use ALEKS'calculator and how to use a TI calculator both. So my first probability that I need to compute is probability of z being greater than 2. So I provided diagram for this. Here's my first diagram. Here's my standard normal curve centered at 0, and I'm finding where z-score will be 2. I would like to know the probability of z being greater than 2, which really means I need to know the area under the curve beyond 2, to the right of z-score of 2. To find this probability, I can also look at it from the perspective of complements, because I can find the probability of the other side, this side, on the other side of z equals 2, and then take that away from 100% area or 1, and that will give me the result. It depends on what tool you're using. So let's talk about ALEKS'calculator. The calculator ALEKS offers only computes probability like this when you have less than or equal to involved. It doesn't know how to do greater than. So that's why we are obliged to use a complement rule and say, instead of finding this area on the right side of 2, let's find the other area on the left side of 2 and take it away from 1. So 1 minus this white area will give me the remaining red area. I'm going to demonstrate in the video how to do this with calculator. Let's talk through the other two examples and kind of get the idea of how we're going to go about it. So next probability is asking us to compute area under the curve when z is less than or equal to 1.38. So I have a diagram. Here's my center at 0. 1.38 is roughly here, and I want area so that z is less than that value. So all those z-scores that are less than 1.38 will be considered. Therefore, all of this area is what I'm looking for. Well, luckily, ALEKS'calculator does just that. As long as you input 1.38 into this function that ALEKS'calculator offers, you're going to know your answer. So I'll demonstrate that later. Let's take a look at the last example. I want to know the probability that of all z-scores between negative 0.58 and 2.05. So here's my rough sketch. So here's again my 0. Negative 0.58 is slightly to the left of 0. 2.05 is somewhat farther to the right of 0, and I'm looking for all these scores that are going to be within this interval, which means all of that area has to be found. Probability of that to happen will be this area under the curve. All right, so how does ALEKS do this part? ALEKS doesn't have a feature to say z-scores from 2. You have to be creative, and here's what we're going to do. Because ALEKS'calculator only knows how to compute area to the left of certain z-score, I'm going to use the following idea. I'm going to find area to the left of 2.05, which means all of this area, all of that area. That's this part. But then I will take away the area I don't want to include, which really is this part right here. I don't want this area to be part of it, so I want to exclude it. So we need to exclude this part. That's why I am subtracting probability of z being less than negative 0.58. So let's see how that plays out with the calculator itself. With the first example, don't forget to start with 1 minus probability of z being less than or equal to 2. So to use a calculator, here we go. Open the calculator, type 1 minus, use p of z less than or equal to some number function embedded into your calculator and press enter. And you got your probability, round to 3 decimal places, 0.023. Next one will be straightforward. Go to this function probability of z less than or equal to input 1.38, press enter. You got your number. Don't forget to round properly. 0.916 is our solution. Last one, remember, you need to take one probability minus another. So just type that in. Probability of z less than or equal to 2.05. Make sure to move outside of the parentheses before you press minus. Input the next probability of z being less than or equal to negative 0.58. Press enter, round to 3 decimal places. That first 8 will be impacted by the second 8 and turn into a 9. 0.699. And we can check our solution. All right, I hope that is clear how we use ALEKS tool. And I give you 3 different scenarios where you use sometimes a complement rule when needed. When you have greater than involved, your calculator can't do that, so you have to be creative. Second example is pretty straightforward. Last one is also, well, requires a bit of tweaking because we have to find the area between two z-scores. So I try to demonstrate all typical scenarios that you will be dealing with. On this page, I would like to demonstrate to you how you can use a calculator to work with similar problems that we just did using ALEKS'calculator. First of all, Texas Instrument TI-84 has 2 functions related to this material. One of them is called normalcdf and another one is called normalcdf. To get to them, you will click on second, vars, which really going to take you to distribution menu, and they will be first 2 functions at the top of the list right there. So what is normal PDF versus normal CDF? What do they do? Normal PDF, if you input the mean and standard deviation and of course the x value, you can compute the height of the curve at this x value. So for example, if I let x be equal to -1, -1 has a corresponding y coordinate of 0.242. If I input, say, I don't know, 0, I guess you can say, how tall is this curve at x equals 0? We can always find the corresponding y coordinate that will be on this curve. I will demonstrate that in a moment with a calculator. Normal CDF is all about the area under the curve, either between 2 z-scores or to the left of a z-score or to the right of a z-score. All of that is dealt with using this function. So let's see a demonstration of all these cases using this calculator. So let's take a look. I'm going to second, vars, distribution menu is open, and I'm using normal PDF right now to demonstrate the first example. X value is -1, mu and sigma are standard, 0 and 1 for any normal curve. And when we compute, we find out that the height of this curve at that point is at 0.4242. Now let's take a look at the other ones, normal CDF this time. Okay, so I want to find the area between -1 and 1. That's this example right here. Well, it happens to be that about 68% of data is there, and I do hope you remember that that's exactly what the empirical rule was saying. The next one, how much area is there to the left of 0.5? So here is where it's a little more interesting. I need to enter negative infinity on the calculator, and here's how we do this. Let me pause this video for a sec. So please notice I typed in I typed in -1 e to the 99. This is how a calculator knows that you're saying negative infinity. So start with a negative sign, go to second and press this double E, which really means press the comma. That's this symbol, and then press 99 after that. That's a standard way to say infinity, in this case negative infinity, to your calculator. The upper side of this interval is 0.5. So let's see. I'm going to continue my video right here. So upper one is 0.5. And then mu and sigma are standard. I just need to compute this function now. And it's going to tell me that area is about 69%. Last example, I want to know area to the right of 2.1. Go back to the same function, normal CDF. My lower bound is 2.1. My upper bound going to be positive infinity. So we're going to type in 1, second, comma, to get that EE function, and then followed by 99. So that's your positive infinity typed in. Press. It means that in this little tiny tail, there is only about, well, roughly 2% of data. So 0.018. So that's how we use these functions on the calculator. Now we're back to the same example that we did using ALEKS'calculator. Remember, we had these 3 examples to complete and we already found the answers. I just copied them right here. Let's see how we do the same problems using a calculator, TI-84. Let's turn it on. So we go to second, vars, to get to distribution menu. Okay. And we are using normal CDF to find area under the curve with given conditions. So my lower bound now is 2 in this first example, in the very first example. I go from, z must be greater than 2, so from 2 up to positive infinity. To type in positive infinity, I type in 1, second, comma, to get to that double E menu, and then don't forget to put 99 in there. No need to change mu or sigma, they are automatically provided. Just press enter a few times and get the number. As you will see, the quantity will be exactly same as we found using ALEKS'calculator. Just round properly. Next example, we want to know area under the curve that is less than 1.38 with respect to z-score of 1.38, sorry. So we have, again, lower bound this time is negative infinity because I need to include all area from the left side of the curve, all of it, up to 1.38 on the right side. So I type that in, -1 e to 99 up to 1.38, and to press enter a few times, you get the answer rounded and you get 0.916. Last example. This one is also straightforward because the calculator lets you type in lower and upper bound. So all you need to do, type in -0.58 and then positive 2.05. Press enter a few times and you will get the same result, rounded to third decimal place as 0.699. Now I would like to come back to the same examples we already completed and to briefly demonstrate how we can use tables to answer the same questions. And these tables are typically included with any statistics textbook. To begin with, I'm going to do the second problem on this list because it's the easiest one when it comes to using the tables. So I'm going to do this second question right here. So I would like to find the probability that z is less than or equal to 1.38, which really tells me to find the area under the curve to the left of 1.38. Here is the first page of the standard normal distribution table. The table has several pages because there are a lot of z-scores that we need to present here. How do we find the right piece of information from this table? Well, according to the visual, for the given z-score, the table provides area to the left of that z-score. In other words, numerical entries represent the probability that a standard normal random variable is between negative infinity and z. In other words, on the left side of z, where z is equal to x minus mu over sigma. Let's say I would like to know how much area there is to the left of z-score negative 1.43. I'm going to look in the column first until I find negative 1.4, and then the 100th place value, which should contain 3, has to be right here. So let's take a look. So here's your 3 in the 100th place. Here's your negative 1.4. So negative 1.43 has this much area to the left of that z-score, 764 10,000ths. This is how we use this table to find the area to the left of the given z-score. The z-score we are working with in our first problem is 1.38. As you can see, there is no positive z-score on this page, so we need to open the next page where the z-scores that are positive, or those that are on the right side of 0, will be listed. Here is the second page. I'm looking for 1.3, and I'm going all the way until I reach 8 in the 100th place. Again, one more time, 1.3 all the way to the 8. The area to the left of this z-score must be 0.9162. As you can see, the result we got previously using other means like TI-84 or ALEKS'calculator gave us the same result as soon as we rounded it to 3 decimal places. Now let's take a look at the first example. We want the probability that z is greater than 2.00, which really means let's find area under the standard normal curve to the right of the z-score 2.00. So that's the one we are doing right now, the top one. Let's find the z-score of 2.00 in our table. I go straight to the second page in my table because I know I'm working with the positive z-score of 2.00. Please notice that the table only tells me the amount of area to the left of the z-score. I want the area to the right of the z-score of 2.00. So if I pretend on this diagram that that is 2.00, I really am interested in this amount of area, not what's on the left. Since table only shows me what's on the left, what I can do though, I can subtract the area that table provides from 1, and that will give me the remaining area in the right tail that I'm looking for. Here we go. I am finding the value of 2.00. Here it is, and my 100th place has to have a 0. The amount of area to the left of this z-score is 0.9772, which means it is this shaded region. So I need to subtract this from 1 to find the area in this little tail over here. This is why when I subtract 1 and 0.9772 we found in the table, it gives me the difference of 0.0228, and when I round it to 3 decimal places as it is requested in this question, I get the answer that we already knew by applying TI calculator or the calculator provided in ALEKS. So table is just another tool that we could use to find the same result. Let's take a look at the last example. If you remember, in this case, we would like to know the area under the standard normal curve between negative 0.58 and positive 2.05. To do so, we're going to find, using the table, the area to the left of the higher z-score of 2.05 and subtract the area to the left of the lower z-score, negative 0.58. And we can find these quantities again using the table. Let's get started by finding the area to the left of 2.05. 2.0 is over here, 5 is over here. They meet in this location, so the area to the left of 2.05 must be 0.9798. And we are documenting that quantity over here. Now let's find the area to the left of negative 0.58. This time I'm looking at the page that contains negative z-scores, and my job is to find negative 0.58. I'm starting with negative 0.5, find the 8, which is over here, and they meet right here, 0.2810. And we again document that quantity. Please remember that we are going to find the difference between these two areas. And we already discussed the reason why this subtraction has to take place when we solve the same problems using calculators. So the difference is 0.6988. When rounded to 3 decimal places, it becomes 0.699. As you can see, the solution is same whether we use a calculator or a table.